So in 7.3d, we're going to use the central limit theorem to help us find probabilities involving sample means. Let's look at this one for texting. Suppose that the number of texts sent during a typical day by a randomly selected high school student, that's going to be important, randomly selected already, follows a right skew distribution with a mean of 15 and standard deviation of 35. Assume the students at our school are typical texters. How likely is it that a random sample of 50 students will have sent more than 1,000 texts in the last 24 hours? So some key things we know now already is this. We know that the mu is 15 and the standard deviation is 35 of our population. We are going to have 50 students send 1,000 texts. So the average of that, by the way, is 20 texts per student if we do that. Okay. Let's state the scenario. What do they want us to find? What's the probability that the total number of texts in the last 24 hours is greater than 1,000 for a random sample of 50 high school students? Okay. That is our actual question at hand here. So how do we find that? Well, let's check our conditions before we compute any means. Our condition here, the first thing I want to do is define my variable. X bar is going to be the sample mean number of texts. So I need to know the sample mean number of texts. That's why I came up in here and actually found the average, the sample mean of texts. So that means I want to find the probability that X bar is greater than or equal to 20. Okay. Let's check our conditions. Well, randomness is very easy. Random sample of 50 students. They set it right here. You do have to write it down though. Independence. Do we meet the 10% condition? Well, I have a sample of 50 times 10, so as long as there are at least 500 students in this sample, I'm good. Okay, so we have to make sure there's that many texters. Now, the normalcy, what I can say here is this. It's approximately normal by the central limit theorem. So what I did is the sample size greater than or equal to 30. Yeah, 50 is greater than or equal to 30. Now, I will tell you, you don't necessarily have to actually say by the central limit theorem, but you have to show that you're checking this condition right here for the calculation. And again, be careful. Don't say it's normal. It's approximately normal. Okay, let's do the do part. We've met the condition, so let's compute the new mean and standard deviation. In this case, we know that the new mean is mu of X bar is 15. Standard deviation of X bar is 35 over the square root of 50. So we actually have that summarized right here for us in our math notation shorthand. Okay, let's do the probability. So the probability for this, the probability that X bar is greater than 20, normal CDF, lower bound, upper bound, new mean and standard deviation. The answer is right here at 0.1562. So let's make a conclusion. We can conclude there's about a 16% chance that a random sample of 50 high school students will send more than 1,000 texts in a day.